very large or very small numbers easier to work with. So I'm going to give you two numbers. Let's see, 0.0. Okay, so I've given you two numbers, one very large, one very small. Put those in scientific notation for me. And when you have an answer for both of them, stand up. There's a decimal right here. Do I need to make it darker? Will it be easier, Bailey? Yeah. Yeah. So when you have them written in scientific notation form, stand up. So I see a few people making these eyes like, I can't make them. Like they don't know what, like they're not sure what they want to do. Is that true? You'll never admit to it, huh? Okay. So let's talk about this. This is a very small number. If I have a number less than 1, what has to be true about the exponent? It's negative. So let's write that down. Number less than 1, the exponent is negative. And y'all know when I say exponent, that's the power of 10, right? The power of 10 is raised to. Okay, so let's count. 3, 6, 9, 10. If I move this 0, here's 3, 6, 9, 10. So I would make this 4.92 times 10 to the negative 10. What's true about this number out in front, this coefficient? What rule does it have to follow? Has to be under 10. So my coefficient must be between 1 and 9.9 repeating. And if it's not, then I have to fix it, which is what we're doing right here. So if my coefficient is less, or if my coefficient is less than 1, my exponent is negative. If it's greater than 10, then my exponent is what? Positive. So here I'm going to have a positive exponent. I just need to figure out what it is. 3, 4, 5, 6, 7, 8. So I would have 7.85 times 10 to the 8th. Now is it coming back to you? If it didn't before? So then the next thing that we have to be able to do is math with scientific notation without the old calculator. So let's look at that. I'm going to start with what I think is the easiest, the multiplication and the division. When you're working this, you either multiply or divide the coefficients. You add exponents if multiplying. You subtract exponents if dividing. And the last thing you want to do is check your form and make sure it fits the parameters, the between 1 and 10 thing for your coefficient. So let's look at one of these. And you will be, when we test over these, you will have a calculator, but you will not have a scientific calculator. So be sure you're getting these things in your head. Let's say that I have 4 times 10 to the third plus times 3 times 10 to the 7th. So I multiply my coefficients. 3 times 4 is what? 12 times 10 to the 7 plus 3 is 10. Now look at my answer. Does it fit my rules? No, it does not. I have to get this to be between 1 and 9.9. I understood decimal is here. I have to move it over and make it 1.2. My coefficient got smaller. If my coefficient gets smaller, my exponent has to get larger by the same 10. It's all based on tens. So if this got smaller by 1/10 place, my exponent has to get larger by 1/10 place. Okay, now you guys try this one. 8 times 10 to the 17th divided by 2 times 10 to the negative 5th. Now look at, yes ma'am.
Why does it have to be between 10? Like, what does that have to be between 10 and 9.99?
Because when we get to 10, this is all based on powers of 10, so we don't want a 10 times 10 to a power. Like we can replace that 10 by making the number smaller and fixing my power of 10. Make sense? The rules are it has to be between 1 and 9.9, 99999 forever. Because if I get to 10, that's 1 power of 10. That's okay? All right, so try this one based on the rules we just talked about.
What that times that is
2 times 10 to the 17th, or 8 times 10 to the 17th, divided by 2 times 10 to the negative 5. When you have an answer, stand up. That's annoying. Where'd you get that?
VCTC.
Oh, yeah.
It's so dark in here. Don't eat it.
Okay. What is 8 divided by 2, people? All right. 4. Now let's look at this. 4 times 10 to the 17 minus negative 5. So that's like plus 5, which makes it 4 times 10 to the 22nd. You people who were standing, did you get that? Don't let the signs mess you up. Yes.
Where are you getting the 10?
Because the 10, it's these 10s. I'm just carrying it through. Other questions about this? We're going to do some more of it tomorrow. Alyssa? You good?
So why didn't you move the decimal for this one?
Because it was between 1 and 10. Okay, so let's look at addition and subtraction. Really pay attention to this one because you have to think harder about this. If I'm going to add and subtract, there are some things I have to do. First of all, the exponents must be the same. If they are not, fix them. Okay, and then you're going to add or subtract coefficients. The exponent does not change unless the coefficient must be adjusted. That means we have to fix it to fit form. So let's just look at a couple of these. We'll start with something super easy. Let's just say I have 4 times 10 to the third plus 3 times 10 to the third. So when you see a plus sign or a minus sign, the first thing you want to do is go to your exponents and go, are they the same? Yes, they are. And then you go, thank you, Mrs. Beal. This is an easy one. Okay, so all I have to do then is do my addition. 4 plus 3 is 7, and I don't have to do anything else. Carry my exponent over. 7 times 10 to the third. Now let's look at one that's not quite so simple. 2 times 10 to the 8th plus 6 times 10 to the 7th. So I look at them and I go, well, crap, they're not the same. And then I say to myself, I must fix them. This is the best way to fix. It saves you work in the end. Take your smaller exponent and make it match the larger. So I'm going to take my 7 and make it an 8. I made my 10 larger by 1/10 place, which means I have to make my coefficient smaller by 1/10 place. Whatever I do to this, I have to do the opposite to my coefficient. So here's my decimal. I move it over here, and this becomes 0.6 times 10 to the 8th. And then I can do my math. 2 plus 0.6 is 2.6 times 10 to the 8th. Remember, make your coefficient larger, make your exponent larger, which makes your coefficient smaller. You're less likely to get into that situation where you have something bigger than 10 if you do it that way. Okay, let's try another one. Let me give you one to try. Let's say we have 5 times 10 to the 7th plus 5 times 10 to the 5th. See if you can do that one. That's a little plus sign in there. It's hard to read. When you have an answer, stand up. This is kind of an icky one now that I really look at it. Who feels confident in their answer? Okay, Bailey, what'd you get? Oh, oh.
Oh gosh, I got 5.05 times 10 to the 7th power.
Okay, anybody get something different than that?
Oh my gosh, I did it wrong.
What'd you, no, it's okay. What'd you get, JT?
1.0
Times 10 to the 13th. Okay, let's check it. I'm not really sure. I do know that 5 plus 5 is 10. So this has to become, before I even do that, I have to fix this, right? So if this becomes a 7, this has to become 0.005. This got larger by 2 tens places. This has to get smaller. Whoops, nope. 1, 2. I put an extra 0 up there. Should be 0.05. So my answer then when I do my addition should be 5.05 times 10 to the what?
You have to add them together.
You have to add them together. No, you don't. We're not doing multiplication. We're doing addition. To the 7th. Is that, who'll have that answer? Good job. Okay. So now, shut your notes. I'm not sure.
Touch our nose?
Shut your notes. Touch your nose. Okay. On that paper, first of all, that orange paper, put your name on it. Shut your notes. This is just a check.